In this video, we're going to demonstrate how to calculate a confidence interval using Microsoft Excel. And so in this file, I have some headings already established, and I'll step through these different headings and describe exactly what it is we're trying to do. But we're first going to go to the right-hand side, and you see two different equations to calculate the confidence interval. The first one uses a z-statistic, and the second one uses the t-statistic. The difference between these two depends upon application. So typically for very large sample sizes, it's not uncommon to use the top equation with the z-statistic. But for studies and data with smaller sample sizes, using a t-statistic would be more appropriate. So to start our calculation of the confidence interval, we do need to calculate some basic descriptive statistics, and that includes the sample average, signified by x bar, and the sample standard error of the mean, which carries the symbol s with a subscript x bar that you see in both of these equations. So I'm going to go over to the left-hand side, and I'm going to start executing Excel commands to calculate the relevant statistics. And so the first one I'm going to do is calculate sample size. And so I'm going to hit the equal sign, and I'm going to type in the Excel command, which is count. I'm going to shift 9, and I'm going to highlight the cells, the array of cells for the data that I have in hand. And to estimate the sample size, I always recommend to highlight the cells with the actual that contain the actual data and not the participant identifiers. So I'm going to shift 0 and I hit enter, and we have our sample size of 9. The next step is to calculate the average score for all of these hypothetical scores on an exam out of 41. So I'm going to hit the equal sign, and I'm going to type in the Excel command average. I'm going to shift 9, and I'm going to highlight the cells over which I want to calculate the average, shift 0, and now I have my average. We now calculate the standard deviation of those data, and I hit the equal sign, and I type in stdev.s for the sample. I could have left out the S, and the default Excel would have used is the sample, but I always type in the .s just to make sure that I am referring to a sample. So I shift 9, and I get the array of cells, and I shift 0, I hit enter, and we have the standard deviation. The next statistic we need is the degree of freedom. That's not going to be something we need for the first way we're going to calculate the confidence interval with the z-statistic, but we're going to need it when we use the t-statistic to calculate the confidence interval. And our degree of freedom is just simply our sample size minus 1. So we hit the equal sign to let Excel know either we're going to type in a function or an equation. In this case, I'm just going to highlight the cell that has our sample size. I'm going to hit the dash, which is subtract 1, and I hit enter. The next thing that we do need is the standard error of the mean. As you can see, that is necessary for both equations. And I'm going to type in an equation to calculate the standard error in this case. So I'm going to hit the equal sign, and that's the equation defined by the standard deviation of our sample. I'm going to // for divide by the square root of the sample size. So I'm going to type in the Excel function sqrt, going to shift 9, and this is the square root of the sample size, not the degrees of freedom. So I just highlight the cell, that's B12, and I shift 0, and I hit enter, and we have the standard error of the mean for our sample data. Two more items that we're going to need is the z-value that we'll need for the first approach, and the second approach will need the t value. So we'll start with the z value, and we're going to ask Excel to look this value up for us. So I'm going to hit the equal sign, and the Excel command for this is norm for the normal distribution, which is what the z value is based upon. going to hit the dot, and I'm going to type in the letter S for the standardized normal distribution. I'm going to hit dot again, and I want the inverse calculation. So I actually want the actual z-value and not the probability level. So, or rather the confidence level. So I'm going to shift 9, and now it's looking for the probability. Now normally we would put 95% because that's the confidence interval we're looking for, but Excel uses a one-tailed probability here, and so the 95% confidence interval that we're calculating is two-tailed, but with Excel using a one-tailed approach, then we have to type in a probability that adds in half of the balance, which is 5%, and half of that is 2.5, so we're going to type in the number 0.975. I'm going to shift 0, and that's at the 97.5% confidence level because this command uses one-tailed. When I hit enter, I have a value of 1.9599 continued, or 1.96 that we'll use. Now we'll go on and calculate the t-value associated with the 95% confidence level. So I hit the equal sign, and the Excel command for this is t dot inverse. So I want the inverse t distribution, and I'm going to signify 2t for two-tailed. I'm going to shift 9, and Excel is looking for two inputs into the parentheses. The first one is the probability level, and because we want the 95% confidence interval, I'm going to type in the probability level outside of that, which is 0.05. We use that with the this command to find the t-value. I hit the comma, and I need the degrees of freedom associated with our data, and that is found right here in this cell. So I could type in the number 8, or I just click this cell, and then I can shift 0, and I hit enter, and we see that the t-value is 2.306 repeated, and on the upper and lower end, this will capture 95% of the area under this particular t-distribution, while 1.96 plus and minus will capture 95% under the normal distribution. So this ends our first video on how to use Microsoft Excel to find the confidence interval.